Hi everyone, welcome back to AR Study Desk. In this video, we'll be learning the line rotation method in projections of lines. It is one of the most important methods in projections of lines. Hope you have watched all the previous videos of projections of lines and all the concepts explained in it are very clear to you. Okay? So before going to line rotation method, we need to know some basics. Now, what did you understand from this drawing? Here, the front view A dash B dash is parallel to XY line and the top view AB is also parallel to XY line. What it means? In the previous lectures, we have studied that when you look at the front view, treat the XY line as HP. Here, the line A dash B dash is parallel to XY line, which means the line is parallel to HP. Now when you look at the top view, treat the XY line as VP. Here the top view AB is parallel to XY line, which means the line is parallel to VP. So from this diagram, we understood that the line is parallel to both HP and VP. Now let me ask you one question. Is this front view the true length of the line? That is A dash B dash, is it the true length of the line? What is the condition to get true length in the front view? In order to get the true length in the front view, the line should be parallel to VP. So, in which view should you look at to know whether the line is parallel to VP? The top view. The top view is parallel to XY line means the line is parallel to VP. Since the line is parallel to VP, in the front view you get the true length. Now, is this top view the true length of the line? What is the condition to get the true length of the line? The line should be parallel to HP. To check whether the line is parallel to HP, in which view should you look at? The front view. Yes, the front view is parallel to XY line, which means the line is parallel to HP, so that in the top view you'll get the true length. Let us see another example. Here, the line A dash B dash is perpendicular to XY line. Very simple. Since the front view is perpendicular to XY line, you can conclude that the line is perpendicular to HP. In the top view, the line seems to be a point, which is named as B brackets A, which says that the point B is nearer to you and the point A is away from you. So this is the front view, right? So when you view from the top, you can see the point B first and then A. So that is shown here. You can see the point B first and then A. Now, is this front view the true length? To know that, just look at the top view. In the top view, the line is parallel to XY line. So, in the front view, you get the true length of the line. Another example. Here, the top view is perpendicular to XY line, which means that the line is perpendicular to VP. Also, in the front view, it seems to be a point. The point is named as A dash brackets B dash, which means that the point A is nearer to us and point B is away from us. So this is the top view, right? So this is when you view from the bottom, this is the front view. So you see the point A first and B behind that. That is why this point is named as A dash brackets B dash. Now is this top view the true length? Just look at the front view. The front view is parallel. This point is towards us, which means it is parallel to HP. So since the line is parallel to HP, you get the true length in the top view. From this, we understood that if the top view is parallel to XY line, you get the true length in the front view. Am I right? If the top view is parallel to XY line means the line is parallel to VP. Then you get the true length in the front view. Similarly, if the front view is parallel to XY line, you get the true length in the top view. The front view is parallel to XY line means the line is parallel to HP. So when the line is parallel to HP, you get the true length in the top view. Hope it is clear to you. Now we will move to another example. This is line A dash B dash. That's the front view of the line AB. Now let me ask you, is this line A dash B dash the true length of the line? Do not answer immediately that it is the true length of the line. You know why? We have studied that If the top view is parallel to XY line, you get the true length in the front view. Which means after seeing the top view only, you can decide whether this is the true length or the apparent length. Okay, so let us see the top view. Yes, the top view is parallel. Since the top view is parallel, you will get the true length in the front view. And this angle will be theta. That is the true angle made by the line with HP. So you get the true length in the front view and the apparent length in the top view. That is top view length, which will be lesser than the true length. Now let us see another example. This is line AB, which is the top view of a line AB. I'll ask the same question. Is this the true length? We have studied that if the front view is parallel to XY line, you get the true length in the top view. After seeing the front view only, you can decide whether this is the true length or not. Okay, so we'll check how is the front view. Yes, front view is parallel. So if the front view is parallel means you get the true length in the top view. And this angle will be the true angle, that is phi. So you get the true length in the top view and the apparent length in the front view, that is the front view length. Now one more example. Is this front view the true length? Now you know that after viewing the top view only, you can decide whether it is true length or not. If the top view is parallel, then this is the true length. If the top view is not parallel, it is not the true length. So let us check the top view. The top view is also inclined, which means that this is not the true length, it is the apparent length. Similarly, is this top view the true length? No. Why? Because the front view is not parallel. The front view is also inclined. So you don't get the true length in the top view also. This is just the top view length, which is the apparent length. So what is the angle made by this front view length A dash B dash with XY line? Is it theta? No. Because if you want to get the angle theta here, this should be the true length. If this has to be the true length, the top view should be parallel. Here the top view is not parallel, so this is not the true length. So this will not be angle theta, but this angle will be the apparent angle alpha. Therefore, angle alpha is the apparent angle made by the front view length when the line is inclined to both the reference planes. So what about the angle made by the top view AB? It is represented as beta, where beta is the apparent angle made by the top view of the line when the line is inclined to both the reference planes. Hope this is very clear to you so that we can move to line rotation method. Line rotation or rotating line method. So here the line we are considering is inclined to both HP and VP. So this is HP and VP, the first quadrant, and here the line AB is inclined to both the reference planes. You will get a better idea when we project this line AB to HP and VP. Okay, so the front view gets projected onto the VP and it is A dash B dash. So A dash B dash is inclined to HP. So the front view length is inclined to XY line. Similarly, in the top view, you get small a and small b, and when you join that, you get the top view length, which is again inclined to XY line. So here the line is inclined to both the reference planes. So what is the angle made by this front view length A dash B dash with XY line? This is not the true length. This is the front view length. This is the apparent length. The angle made by the front view length with XY line is alpha. That is apparent angle alpha. Similarly, the angle made by the top view length with XY line is beta. From the line rotation method, you are trying to get the true length of the line and the true angles made by the line with HP and VP. So let us see how do we get the true length and the true inclinations with HP and VP. Now I will rotate this line AB about A so that the line AB is parallel to VP and inclined to HP. You can see that when I rotate this line, the projection also gets rotated and the top view is now parallel. So the point B has shifted to a new point, so I'll name it as B1. Okay, so directly below B1, I'll be getting the point small b1, which represents the top view of this point. So now the top view AB has been rotated and made parallel to VP, and the name of the line changed to AB1. Now it is parallel to VP. Okay, so what is the angle made by AB1 now? Look at here. It will be theta. So this is the true angle made by the line with HP. Now if I project AB1 to VP, what will I get? I will get the true length projected on VP. Look at here. Is it clear? So this is point B1 dash, so that I'll get the true length on VP. And it is very interesting to note that the point B dash and B1 dash will be along the same locus, that is locus of B dash. Why? Because when I rotate B to B1, it moves along the same height. It is not going down or going up. So the projection of B and B1 should lie on the same height, that is locus of B dash. So what is this angle made by this true length with XY line? That will be theta. Hope it is very clear. Now, in order to get phi, what should I do? Phi is the true angle made by the line with VP. Okay. So what you should do? You should rotate the line and make it parallel to HP so that you can see the true length in the top view and the true angle in the top view. So what I'm going to do is, I'm going to rotate this line AB about A and make it parallel to HP like this. So the projection of B also gets rotated when I rotate line AB. So I get a new position for AB. So what name should I give it here? I cannot name this as B because B is already taken. I cannot name this as B1 because B1 is also taken. So I'll name it as B2. So the name of this point will be B2 dash because it is the projection of point B2 in the front view. So A dash B2 dash is now parallel to XY line. That is front view is parallel. That means in the top view you should get the true length. Now what is this angle made by this line AB2 with XY line? This angle is phi, which is the true angle made by the line with VP. Okay. Now if you project this AB2, this is the true length. If I project this onto HP, you get the true length. Look at here. Yes. So you get the point B2 over here, which is the projection of capital B2, and this is the true length. B and B2 will be lying on the same locus of B. And the angle made by this true length is nothing but angle phi. That is the same angle that you get here. Hope the concept is very clear. Now we will see how to put this in a paper. Draw the XY line. You have the line AB which is inclined to both the reference planes like this. This is the front view length, this is the top view length, this is angle alpha and this is angle beta. So in order to get the true length in the front view, what you should do? So just rotate the line AB about A so that B gets a new position, that is B1. Now the top view AB1 is parallel to XY line, which means that the front view A dash B1 dash will give you the true length of the line. Okay. So in order to get the point B1 dash, what you should do? You should draw the locus of B dash because B dash and B1 dash will be lying on the same locus as we discussed here. So just project this point B1 till the locus of B dash so that you get the point b1 dash. Join a dash b1 dash to get the true length, and the angle made by that line will be theta. Now what you should do to get the true length in the top view? In order to get the true length in the top view, the line should be parallel in the front view. So rotate the front view about a dash. So b dash gets a new position here like this, and that will be nothing but b2 dash. Why? Because it is front view. You can't name it as b dash because b dash is already there. You can't name it as b1 dash, it is already there. So you take another point b2 dash. Now the front view a dash b2 dash is parallel to xy line, which means that in the top view you should get the true length ab2. So you have a here, you need to get only b2. Where will be b2? It will be on the locus of b. So just project this b2 dash till the locus of b to get b2 and join ab2. This will be the true length of the line, and the angle made by the true length ab2 with horizontal will be nothing but the true angle phi. Hope the line rotation method is very clear to you. You can practice this using the problems in our app. You can download the app from Google Play Store and subscribe to get access to more than 200 questions on engineering graphics. Thank you for watching. Happy learning.